Hello and welcome to this video. My name is Max and on YouTube I'm called Dr. Donald Duck, and today I'm going to talk about my favorite mega number. As an introduction, many math YouTubers have come together for one big project where we all make a video about our favorite mega number, where a mega number is a number bigger than 1 million. In the top right corner you can see a video by James Grime on that topic, and I've put a link to the playlist with all the videos on favorite mega numbers in the description. Okay, so my MegaFave number is approximately equal to e to the power of 100 minus gamma, where e of course is Euler's number and gamma is the Euler-Mascheroni constant. Now you might ask, what is the Euler-Mascheroni constant? Well, guess what? You will learn that soon. So let me first give you an introduction to something which is called the harmonic series. Now, what is the harmonic series? The harmonic series is this. The harmonic series is 1 plus a half plus a third plus a fourth plus a fifth plus 1 over 6 plus 1 over 7 plus 1 over 8 and so on up until infinity. And the question you can and should ask now is the harmonic series convergent or divergent? In order to find that out, let's just have a look at two different series. The series S1 is our harmonic series, 1 plus a half plus a third and so on. And the series S2 is just some other series, which is 1 plus a half plus a quarter plus 4 times an eighth plus 8 times a 16th and so on. So you might ask, what is the special thing about this second series S2? Well, as you can see, I've highlighted several fractions by color because you can put that series S2 together to 1 plus a half plus a half plus a half plus a half and so on. So you can put that series S2 together to 1 plus 1 plus 1 plus 1 and so on, and therefore the series S2 definitely diverges towards infinity. Something else you might notice is that for each term or fraction in S1, the corresponding fraction in S2 is always less or equal, but never greater. So as you can see here, every fraction in S2 is either equal or smaller than the corresponding fraction in S1. And since S1, the harmonic series, and S2 can be split up such that every summand of S1 is either greater than or equal to the corresponding summand in S2, every partial sum of S1 of the harmonic series is greater than or equal to the corresponding partial sum of S2. So what we now know is that every partial sum of the harmonic series, every harmonic partial sum, is greater than the corresponding partial sum of S2. But what we also know is that S2 blows up towards infinity. So we know S1, the harmonic series, is always bigger than S2, and S2 goes towards infinity, therefore S1 also goes to infinity. And since S1 of course is the harmonic series, we have now proven that the harmonic series blows off towards infinity and therefore is divergent. Okay, so now let me tell you something about the Euler-Mascheroni constant gamma and its use at approximating harmonic partial sums. Okay, so what is a harmonic partial sum? We know that 1 plus 1 over 2 plus 1 over 3 and so on is the harmonic series, and 1 plus 1 over 2 plus 1 over 3 and so on up until 1 over n is the nth harmonic partial sum. Now we can have a look at all the partial sums, and apparently Hn, so the partial sum, the nth partial sum, Hn minus ln of n converges towards a value which is approximately 0.577 and now known as the Euler-Mascheroni constant gamma. From the fact that Hn minus ln of n tends towards gamma, we can deduce a formula which gives the approximate value of Hn, getting more accurate when n gets bigger. And this mysterious formula is obviously Hn is approximately equal to the natural logarithm of n plus this mysterious gamma. So actually we have a logarithmic growth here. Okay, so to come to an end, I would like to present to you the ant on a circle problem and my MegaFave number. So pretend there is a circle with circumference 1 meter and there's an ant on the circle. And this ant walks in the first second 1 centimeter. So after 1 second, the ant has traveled 1% of the circle or of the circle's circumference. And after 2 seconds, because the circle is elastic, it expands to 2 meters circumference. So in the second, the ant walks again 1 centimeter, which is now 0.5% of the whole circumference because the circle has expanded. So after 2 seconds, the ant has traveled 1 plus a half equals 1.5% of the circle's circumference. In the third second, the circle expands again by 1 meter. Now the new circumference is 3 meters. And in the third second, the ant walks again 1 centimeter, which is now 1/3% of the whole circumference, meaning after 3 seconds, the ant has traveled 1 plus a half plus a third equals 1.8333% of the circle. And this continues just and so on up until infinity. So always the circle expands by 1 meter and the ant walks 1 centimeter. And now there's one question you might ask now, and you even should ask now. And this one mysterious question is, will the ant ever have traveled the whole circumference of the circle? And this question is not that easy, but with this knowledge we have now about harmonic series, we can answer it. Apparently, after n seconds, the ant has traveled 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 and so on up until plus 1 over n% of the circle. So approximately after n seconds, it has traveled ln of n plus gamma % of the circle, because after n seconds, it has traveled the nth partial sum of the harmonic series % of the circle, and ln of n plus gamma is the approximate formula for that. Since the harmonic series Hn diverges, one day the ant will definitely have traveled 100% of the circle, because one day, because it diverges, Hn will reach 100. Now the question is when? When will Hn reach 100? When will ln of n plus gamma will be equal to 100? Of course, this is just an approximation, but it's a quite accurate approximation, so we can work with that. So we can solve ln n plus gamma equals 100 for n, and this gives us n is equal to e to the power of 100 minus gamma. And I think this is mind-blowing. So therefore, after about e to the 100 minus 0.577 seconds, which is more than the current age of our universe, the ant will eventually have traveled the whole circle once. I think this is mind-blowing and so intriguingly long. This ant takes more than the current age of our universe to just walk around this circle once. I think this blows my mind, and that's why this is my mega fave number. If you would like to have a look at the whole PDF I wrote for this video, you can download it by the download link in the description of this video. Now, I hope you enjoyed the video, and I am really looking forward to reading your comments, including, of course, questions and also suggestions for upcoming videos. Okay, so now I don't have anything more to say. I hope you enjoyed the video. Have a good day and stay healthy, and if you have been, thanks for watching.